A customer sent in their Vizio power supply for an M75-E1, and the issue the customer was experiencing was that the TV had power, it was working. All of a sudden they heard a very loud pop, the set shut down, and it never came back on again. So we're going to take a closer look at it and see what we need to do to fix it. Now the first thing I'm noticing here is that our fuse is missing. So the customer, I believe, did remove that fuse. And then taking another look over here, I'm seeing that this capacitor and this capacitor over here are both burnt. Now what's kind of unusual is I believe typically these components over here are the ones that get damaged, and we typically see damage to the capacitors down here. However, I'm not seeing any damage to these guys or anything in this area. Okay, something else I'm noticing is we have a little bit of a brown spot over here. So if we zoom in, it's a little darker right there. And if we flip the board over, it looks like this is the component that has the heat stress. So we're going to take a closer look at that if we have any issues post-repair. And actually, now that we have the board flipped over, I'm noticing that this transistor and this transistor have been touched up, which are these two guys right next to the damaged capacitor. So perhaps they did try to replace these. I'm not sure. They did not tell us they made any repair attempts, but clearly someone has worked on this board before. All right, the first thing I'm going to do is we're going to go into continuity mode. So when we have a short, we get a beep. We're going to check these diodes down here. No short, no short. And this transistor over here, no short, no short. Okay. Now the reason I did that is, as I mentioned, this area is the area that typically gets damaged. All right, let's slide the board down. Now these are the two capacitors that are physically burnt. So let's check the transistors next to it. No short, no short, no short. How about this one over here? We have a short. Okay. And we have a short here, but not on this leg. So the first thing I'm going to do is I think we're going to go ahead and replace these two transistors. And because the customer already replaced these over here, I don't know that I can trust them. So I'm going to go ahead and replace them again. I'm going to turn the board around and take a closer look here. And that is K13A50D, K13A50D. So these two over here are K13A50D, and these two over here are a little different. They are K10A50D. All right, the first thing I'm going to do is unscrew these guys. Now we're going to flip it over, and we're going to desolder all four of the transistors. All right, and due to popular demand, we're going to be using our desolder pump. Which is not working at all. And we're not making much progress here. Okay, that's a little better. Okay, and our first two transistors are out. Let's go ahead and do the second two. And these, like I said, I think the customer may have replaced them. And there goes our second set of transistors. Now we're going to go ahead and remove our capacitors. So we have 4 capacitors we're going to remove. We're going to remove this one over here that's not burnt yet, this one over here that's clearly burnt, this one over here that's also clearly burnt, and this one that is not yet burnt. Our first one is right over here. Then over here. And you know what? We're going to add a little bit of solder. There we go. Just to get the flow going. Alright, and we should be able to wiggle these out now. So the transistors over here that were the K10A50D are 10 amp 500 volt N-channel MOSFETs, and the ones that were over here were the K13A50D, which were 13 amps 500 volts. And I don't have either of those. However, I do have some that are rated for 20 amps and 600 volts. So we're going to use those instead, since they're rated for higher voltage and amperage. We're going to go ahead and clean up the thermal paste on the heatsink here. Get a nice clean surface for our new components. So we're going to go ahead and pre-bend some of our pins. Okay, now these over here, we're not going to put thermal paste on, but these two over here we will. So we're going to put some ceramic 2. I'm going to go ahead and rub them against each other to get a nice spread on both sides. Alright, let's go ahead and flip the board over. And it looks like my middle pin is not going through, so we're going to have to push that through. Alright, and now we can go ahead and solder the new transistors in. Let's place our next one in here. And as I flip the board, I'm going to hold those two with my fingers. Alright, and that's kind of a bad soldering job. So we're going to add just a little flux. And we're going to clean all that up. There we go, that looks a lot prettier. Let's go ahead and cut off the excess from the leads. We'll do the same on the first two. Give it all a quick little clean with some isopropyl alcohol. Now the capacitors that we're supposed to put back in are going to be 101K, 1kV as the rating, and that's going to be the same for all 4. Okay, I'm going to go ahead and hold those down with my fingers on one side, and back here what we're going to do is I'm going to bend the pins out a little bit, and that's going to lock in our capacitor. And we're going to do the same over here. Alright, and now we can go ahead and solder those down. And then same thing, we'll cut off the leads. So before we move forward, I just want to confirm that the components we just replaced were indeed defective. So these two in the center are the originals. And we have shorts on both of them. So both of these were defective. Now let's make sure the new ones are not shorted. And they are not. So we've resolved that short issue. And these two over here were never shorted. Let's go ahead and check them anyways. Still not shorted after we replaced them, so we're all set there. Okay, the last thing we're gonna do here is install a new 10 amp 250 volt fuse. And again, the customer had removed the original, not sure why. I assume it was defective, but we've just replaced it now. All right, and then we did have this little brown spot here. So let's flip the board over. We're gonna take a close look. All right, so aside from just some heat stress, everything looks just fine. I don't see any issues. We can do a quick short check. No shorts on these diodes. No shorts here. Okay, I think we're ready to live test. So I have my little power on switch soldered directly to the board so we can power on the board without the main board or the rest of the TV. So let's power it up. And we're going to do a quick measurement before we turn it on to the filter capacitors. And we're getting 169 volts and nothing popped. Our fuse is good. Let's go ahead and turn it on. Let's recheck now our filter capacitors. And we're now getting a steady 390 volts, 391. And the important part is that it's not oscillating up and down 5, 10, 15 volts. All right, perfect. So then let's do a couple checks. Do we have our voltage output over here? We're looking for 24. And we are getting 24 volts. Okay, what about over here? Yep, we're also getting it. Finally, we also have some 19 volt lines over here. And sure enough, we're getting our 19 volts. Okay, so it looks like we have a successful repair for the M75-E1 power supply. If you're interested in sending in a similar power supply for us to fix, we'll have links to our flat rate services in the video description down below. Otherwise, if you found the video helpful or useful, make sure to leave us a like, subscribe for more, and thank you for watching.